Hey everyone, welcome to graphing logarithmic equations, horizontal and vertical translations. This is just a couple extra examples if you need them for class. So we're going to just talk specifically about translating graphs left and right and up and down. That's translations, okay? So just a reminder on what we know about logarithms and exponentials. They are inverses of one another. So what you're seeing over here is when the b value, the base, is greater than 1, and when the base is between 1 and 0 here. Okay, so just some common things. Here's b to the x in blue and logarithmic in red here for both of those graphs. So with exponentials, we know the y-intercept is 0, 1. Domain is all real numbers, and the range is from 0 to infinity, and the horizontal asymptote is y equals 0. Now, what happens here is that when you have an inverse, things switch. Okay, the x and y switch places, basically, if you were going to solve that equation, or from a graph. Notice how 0, 1 becomes 1, 0. They're switching places, okay? The x and y are, and it's the same thing here. The y-intercept becomes the x-intercept, so 1, 0. Or 0, 1 becomes 1, 0. See how the x and y switched? Now look at this domain becomes the range down here, and the range becomes the domain of the logarithm, so they switch. So if you don't see that, if you just look, and if I was going to draw, these match up and these match up, they switch places. The x and the y switch, so the range of the exponential function is the domain of the logarithm. The exponential function has a y equals 0 asymptote, the x-axis right here. And the logarithmic function has a vertical asymptote here and here. Okay, so let's go ahead and graph a couple of these and see how we can do these. Now, there's a lot of different ways you can do this. Okay, now, as before, you need to state the domain. We're going to graph and state the domain and range of each function. Okay, so in part A, okay, I'm going to go ahead and I'm going to say the domain of y. Now, this graph is a shift of 3 units right. Okay, even though there's minus sign, it's opposite for h value inside the parentheses. So we're actually moving 3 units to the right. Okay, so in our domain video, we know that x minus 3 has to be greater than 0. So if we add 3 to both sides, so x has to be greater than 3. So if we wanted to write that in, we could say 3 to infinity. Okay, that's the domain. The range of this function is just going to be all real numbers. Okay? Even though it's a shift, it's all real numbers. So there's our domain and range. Now, to graph this function, there's a lot of different ways you can do this. Okay? The base is b, so the parent function, or the inverse, is y equals 2 to the x. So I can plot that first. Okay? So you're going to end up seeing 3 graphs here when I draw this. So I'm going to go ahead and draw 2 to the x. Okay, 1, 2, I think that's 5. So we'll do that in blue here. Keep it consistent. So 0, 1, 1, 2, 2, 4, and negative 1.5. So here is our 2 to the x function. Okay, so we should have a good understanding of what that looks like. Now, if I want the inverse, if I want the logarithmic function, log base 2 of x, I just switch. 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. And if you had negative 1.5, it would be now 1/2 negative 1, maybe right there. So now here is log base 2. Now that's not what I need. I need it to be 3 units to the right. So guess what? With the red function, okay, I'm going to go ahead and move all my points 3 units to the right. So each one of these. So 1, 2, 3, 1, 2, 3, and 1, 2, 3. The y values are not changing. Now, this value up here, the k value, the outside used to be give us the horizontal asymptote. But now, with the log function, this value here is going to give us the vertical asymptote. So we move 3 units to the right. So the domain said 3, so we have this imaginary line right here. And so now we know our graph is going to follow that right there. So here is log base 2 to the x minus 3. That's the graph in green here. Okay, domain and range already stated. So let's look at the second one here. Now this one, if we look at it, it's x minus 3, but the 3 is on the outside. So this is going down 3 units. Okay? Now we know it's log base 2 of x, so we can actually just plot this function here. We can skip plotting the exponential first. Okay, so when I go ahead and plot this, we're going to plot it and then we'll state the domain and range. I'm going to go 1, 2, 3, 4, 5, 1, 2, 3. Okay. I'll put in red log base 2, so we're going to have 1, 0, 2, 1, and 4, 2. So here is roughly log base 2 of x. Now I have to shift all of these points down 3 units. That's what this is saying. So let's shift them all down. Okay? So 1, 2, 3, 1, 2, 3, 1, 2, 3, and our graph is going to look something like this. Okay, I shifted all those points down 3 units. Okay, so that's a couple of examples of horizontal translations. When you look here and we shift everything down 3, our domain doesn't change. It's still 0 to infinity. I did not shift left or right. Okay, and the range is actually not going to change either. It's all real numbers, even though I shifted the graph down 3 units. Okay, so that's how you do horizontal and vertical translations using with logarithms. Excuse me. If you guys have any questions or comments, let me know, and we'll see you next time.